Good afternoon and welcome to METALCON Live. I'm Judy Geller, Director of METALCON, here with Kaylin Burke, and we are very glad you could join us today for Demystifying Rainscreen Systems, Utilizing Metal Wall Systems, brought to you courtesy of the Metal Construction Association. There are a lot of benefits to signing your company up for MCA membership. So for complete details, please contact Jeff Irwin. His info is on the slide that's currently on your screen. Today's session is being presented by David Weidel. David has a world of experience working with architects and contractors in his role as Architectural Business Manager at ATAS International. You can send your questions via chat to David, and he will answer them towards the end of his presentation. Also, to receive your AIA credit, you must attend the full webinar and answer the post-webinar survey. And be sure you include your AIA membership number. Finally, February is going to be a busy month for METALCON Live. On the 10th, we hope you'll tune in for our quarterly metal construction industry trends panel with PSMJ's own Frank Stasiowski, who will be joined by Tony Buquois of the MBMA and Alex Carrick, Chief Economist with Construct Connect. On February 18th, we're really excited to be launching the Metal Focused Safety Program. Craig Shafter from Safety Works is teaching, and registration is now open. I think that's all the announcements I have for today, so let's get on with the program. So David, take it away.
All right, thank you. Hopefully I'll be able to stand up with this glowing recommendation you gave me. The host has disabled my screen sharing.
Can you enable?
There we go. Okay, have we got it? Can you hear me?
Yes, we can.
Okay, just want to be sure. Okay, we're going to go through demystifying Rainscreens concepts here. What we're doing is identifying the importance of air and water resistive barriers in energy efficiency, discovering the importance of integrated continuous education. We're going to talk about the various types of Rainscreen systems, and towards the end we're going to talk about simplifying some energy efficiency using IMPs or insulated metal panels. So with that, I mean, the presentation is really intended to explain right now what is an overused term of Rainscreen terminology. We hear it all over. This basic understanding is more a two-stage method of weatherproofing or drain back ventilated assemblies in building envelope enclosures. So if we look at a wall assembly, what we're talking about, it needs to be durable, it needs to be of an economic value, and an aesthetic value as well. And that's just right in metal's wheelhouse. We're going to control the heat, the air, and the moisture flow. We want to deflect any rain or rain penetration. We're going to drive the vapor in directions that we want it driven and protect it from light and solar and other radiation that's out there. There's noise and vibration issues that we want to prevent, and there's also fire issues that we want to prevent as we go through this. So when we look at some of the history, it goes way back, even in the early Norwegian area, the 1400s, people were opening cladding in barns. We like to look at it a little bit later on in its evolution. We look at the Rainscreen, and what we're doing is, so the water vapor that's coming in is automatically removed by ventilation of that space. And that's pretty much been around since the 1940s. In the 1950s, we started talking about those cavities and how to provide that. And here recently with the building science and the evolution of the codes, what we have is the perfect wall assemblies. Everybody's heard of that from the Building Science Corporation. And that's more of an open vapor profile that we'll get into a little bit, but you can see the concept has basically remained the same all the way through its evolution. And now with the current code updates and the continuing insulation, we've got a little bit more, what I consider a little better avenue for the metal panels to adapt to this type of construction. So when we look at it, you're looking at an outer leaf and an inner leaf for the two main components. On the outer leaf, you've got your cladding, be it metal, be it masonry, fiber cement. Then you have your airspace. Your inner leaf consists of your insulation, your weather resistive barrier, and your building structure itself. So if we take them one at a time, you're looking at your exterior cladding. And what that's doing is basically controlling water infiltration. I like to think of this similar to CSI does the 3 C's of construction: clear, correct, concise. I like to think of this as, deflect and manage your moisture, drain any moisture that gets into the assembly, and assist in drying out that assembly. So really your cladding, it provides your UV protection and your environmental load resistance. And just a quick picture. If we look at the airspace, it's your ventilation cavity. It's your drainage plane, and air flows up, moisture flows down. In a pressure equalized system, it's a little bit different. It facilitates that rapid pressure equalization in compartments throughout the building area. So how do we make that? Typically with a single skin wall assembly, what we're looking at is creating that airspace off of the continuous insulation. We can do it a couple different ways, and we'll talk about that further in. With insulation, right now with the codes, continuous insulation is the way to go. You don't have a choice there. It's even in residential now that we see with the new ASHRAE codes. It should be of a water resistant material, and it should minimize any condensation and thermal bridging throughout. There's a couple different ones that are standard. You've got the mineral wools, you've got polyiso, you got extruded insulation, spray foams are out there. There's sit panels and structural panels where the insulation's already bonded. And one of the newer ones that we're seeing as part of the continuous insulation trend is with the IMPs, or the insulated metal panels. So then there's one of the major areas of concern, and that's your air barrier, your weather resistive barrier, as we like to call it. That's something that right now, depending on the placement, depending on the location, depending on what you're using the building for, that is something that we have to take a very hard look at. This can make or break your air assembly, or your total building enclosure assembly, should I say. But what we're looking at is you've got moisture that is being driven through that to the exterior, to the cold side, and you've got the cold side that's coming in contact with that moisture and causing condensation. And then you have your building structure itself. It can be brick, it can be block, it can be wood or metal framing. And it can incorporate different facing types. There can be plywood, exterior sheathing, exterior gypsum board, are all part of the assembly. And if you take a look, here's a metal framed structure. So if we look at the different wall assemblies that are out there, you can see you've got the face sealed assemblies. The single skin components were originally designed to be face sealed assembly. Then you have the drainage plane where you've got the drainage behind. You've got pressure equalized systems where you have pressure equalization in the compartments where you've got the drainage intake and the exterior exhaust. You've got the drainage cavity systems that we're talking about, the drain back assemblies. And you also have the mass wall assemblies that are out there. The mass wall is a very good indicator of what happens in a building envelope. With the mass walls, you've got, as long as that mass is big enough to stop that infiltration of moisture, and there's a way for that moisture to get out, that's a very viable solution. But you add the increased R values with the new codes, it makes it very hard to do in a mass wall assembly. So the thinner you can keep that assembly, the easier it is on your other parts of the system, your penetrations, your windows, your flashings, your detailing, all the way through, all the way into your structure. So if we look at a typical wall construction with a vertical panel orientation, you'll notice a couple things here. You've got the panel going up and you've got your subframe. But in order to create that drainage plane, you have to use an additional subframe member to pull that away from the wall so that you've got that open drainage assembly all the way through. And you can see here in a vertical orientation that metal adapts very well to the buildings that we're building today. In a horizontal application, it's a little bit different. You've already have that vertical subframe there that you're attaching your metal to, and that automatically creates your drainage plane. So that makes it a little bit easier. You've got your panel, you've got your vertical subgirt or CI channel or some type of subframing member there. And then you have your continuous insulation, your weather resistant barrier, your exterior sheathing, and your framing as it goes through. And in a horizontal application, again, these are the types of buildings that we're seeing today. And it just fits so nice with the aesthetics and the fact that it's lightweight and it's durable and it does its job. Metal's been around for a long time, but we've seen a real resurgence in the wall assemblies here in the last 10 years. But with the rain screen options, we've got a couple different ways to go. You've got the drain back ventilated, which we're talking about here today. And you've got the pressure equalized rain screens that are out there as well. With the drain back ventilated, what we have is a series of sheets or panels of the cladding that's attached to vertical supports, and that's the exterior layer, your durable deflection that we talked about earlier in the presentation. It's designed to minimize but not prevent water penetration. You can see here another picture of metal just adapting to its use. So any water that does get in, it has to be controlled and drained to the exterior. One of the nice things is that cavity depth is typically controlled by the porosity of the cladding itself. So metal, you're looking at that 3/8 to 3/4 inch. We don't need that great big wide open space. There's no slag behind that we're worried about in some of the other cladding applications. So that keeps your wall thinner and it's easier to flash. So with the drain back ventilated systems, there's a couple ways that this is tested. What we have is AMA 509. It basically is a quantitative test, and you get water penetration ratings from W1 to W11. So you've got no infiltration to excessive infiltration. This isn't a pass-fail type test. This is a quantitative test where you're looking at what happens as the system works in different applications. So showing the same picture again, you've got your panels and your clip and your fastener attaching onto your vertical substrate. That substrate, your vertical subgirt, is attached through the insulation into your structural framing member. So with pressure equalized systems, these tend to be more design intensive. They use compartmentalization. They limit the water passing through the outer cladding by pressure equalization in different compartments of the building. They try to reduce or eliminate the rain and the wind-driven forces. So the thing to remember is non-compartment ventilation cavities cannot be classified as pressure equalized, as because the large volumes of water can get in and result in varying cavity pressures. It's very design intensive. It's highly engineered. The quantity, the geometry of not only the openings, but the building itself and that cavity volume all have to be taken into account. It should be engineered with assistance from your HVAC or your MEP as you go through that design, because he's going to have something to say about the pressurization of the building itself, whether that be positive or negative. That test is very similar. It's on a 508. There's been an update in 2014. And what this does is this tests the weather resistance of the assembly. What they're doing is making sure that you achieve that pressure equalization between the inner leaf and the exterior cladding. And that is a pass-fail type test. And you can see here in these details, you can see where the ventilation path for the air and the pressurization and also a drainage path for any moisture that gets into the system as that goes around the clip assembly into that compartment. Normally we'll see this with a metal composite material, but there have been some applications on higher rise buildings with metal panels as well. So there are some very similar elements in the design. The design of the air and water barrier is a prime consideration. Kudos to the Air Barrier Association. They've developed a master spec that details these design considerations and should always be addressed. If you need their contact information, feel free, I'll pass it along. They've done a great job in assisting in this complicated portion of the building itself. The cladding joinery is designed and it's altered to create those extensions back to the face. The pressure is controllable in those compartments with the the PER system, and it is engineered and tested differently. So you've got the two different tests. Normally what I see a lot of with the metal panels is we look at panel test for the panel itself. You've got ASTM 283 or ASTM E331 for your water and air infiltration, but that's just for the panel. It's not for the total system. And I see as we get further and further and further into the building science, we're seeing more how the system elements play together, and the entire system should really be evaluated instead of just picking out an ASTM for this portion of the building, an ASTM for that portion of the assembly, and combining them together in hopes that they work. This is a mock-up for AMA 508 and 509 type test. You can see they've got the fan for the wind-driven moisture goes in, but there's one thing that missing in this test, and I think that needs to be clarified a little bit, is that there are no penetrations here. And As everybody knows that's on this call, the penetrations and the detailing make or break a building envelope assembly. So I think it's nice to know these quantities, and these quantities should be tested, but we need to define the assembly of the building. If you have what we've seen earlier, where you have the extensions and the little balconies, and you have a window every 3 feet, those need to be incorporated into these test assemblies. Personal opinion. So you can see here's another horizontal one where they're using color to define building height. So within the drain back ventilated systems, you've got a couple different applications. You have a vented wall and you have a ventilated wall. The ventilated wall, very simply, is one that has an opening at the top and at the bottom of the cavity to promote air circulation and drying. In a vented wall, there is only one opening, normally it's at the bottom, to provide drainage. And that provides a minimal volume of air circulation to dry out that assembly. So with the vented system that allows for drainage of the moisture, the ventilated systems increase the air movement, which can increase your drying rates. Ventilated systems can promote drying of moisture-laden air, moisture present in construction materials, and also moisture that's introduced either by the building use or by construction assembly as it moves through the different cycles of your construction schedule. So the air spaces can eliminate capillary flow between that cladding and the interior sheathing. Water that's passed through that cladding can drain out. The water vapor in the air is transported by diffusion or air movement through that wall to the exterior. The stored moisture within is further dries the wetting from construction cycles, like I was saying earlier. If you think about how we build buildings now, the fast track is no longer a thing. Everything is fast tracked as we go through. With these ventilated and vented wall assemblies, they can reduce the potential for corrosion, discoloration, mold, and rot. You desorb moisture within that cavity, and porosity can affect the design. And that's why metal plays so well, because it has no absorption value. And that cavity depth can be reduced, to serve its main function, which is to ventilate that system. So the drying rates are dependent on all types of variables. You've got the width of the cavity, you got the inner leaf, the outer leaf assembly, the type of the cladding, the drying rates of both the cladding and the insulation. You've got ventilated and vented systems are often used in and talked about and designed interchangeably. It's up to that designer to select those that type of system based on your desired outcome and the characteristics of what you're building the building for. And we can see here just a quick pick. These don't have to be the standard single skins. Now we're seeing the modular systems, the shingle systems, all these are being incorporated into the drain back ventilated assemblies. So with a vented assembly, you have down at the bottom, you can see that little J channel, perforated J channel in this case, behind your base trim, which provides a way for the air and the water to move out of the assembly. With a typical vented ventilated, system, you've got that vent trim at the top as well. So you're actually moving the air through the system and increasing that ventilation rate, and that increases your drying ability. You can see here in a building mock-up where everything was mocked up, and you can see that ventilated channel at the base trim. So we've talked about that airspace, but how do we create it? There's a couple different ways we can go about it. There are drainage mats out there that you can use. Some of them are semi-rigid. That ventilation drainage mat works very well when you're doing a shingle type or a non-structural type panel out there. There are above sheathing ventilation shims that are out there. These can help with the reduction in the subframings where you don't want to increase the width of that wall assembly. These are stackable. You can do them 3/8 inch up to 1 1/8 inch, and it can minimize the effects of that condensation on the backside. You can do shop form hat sections. They're out there as well. We've seen quite a lot of this here recently. And there are self-adhered shims that can be used to pull that framing member away from your insulation and your weather bearing. There are also some highly engineered systems out there on the market. You can see with the one on the top, it has the plastic spacer on the back, and the green Smart CI girt down on the lower center has the fiberglass wrap, and that reduces your thermal conductivity throughout that assembly. Because with continuing insulation, that definition is that it's continuous across all the structural members without thermal bridging other than fasteners and service openings. So it's integral that you do not want to be transferring any of that heat from inside the building to the outside of the building. And you want to ensure that you have your thermal breaks going all the way through. But if we look at some of the IEC codes that are out there in the different zones, we do a lot in the Northwest. So a lot of what we do is a function of controlling the heat from the inside of the building going out to the cold. But if you notice the white line going down here, down through Georgia and Alabama, that's pretty much the warm, humid areas. You may be doing just the opposite and trying to prevent the cold from migrating to the warmth. So it's always good to have a nice relationship with the weather barrier manufacturer. Your cladding attachments can affect your thermal performance. Everybody has seen the thermal imaging of what we thought was continuous insulation, but the members coming through supporting the awnings are basically heat sinks. So what we're looking at is the conductivity of the material penetrating the insulation and the amount of contact area there for all of those parts. Like we talked about earlier, some of your common insulation materials are used continuously over and over again in building assemblies. You've got your rigid foams, you've got mineral fiber, you've got insulated metal panels that have really taken off as one of the newer ways to create this continuous insulation assembly. So you can see here with a CI girt, what we have is a trademark thermal stop fastener isolation. And what this does is actually isolates any thermal transfer from the fastener going out into that subframe system. The weather resistant barrier. It's the last and one of the most critical lines of defense against water infiltration and vapor infiltration. It minimizes condensation. It's water and air are two separate things. The vapor transmission and permeability values can vary, and it's one of the most important things we need to keep in check here. That golden rep that you need to bring him online, because it's not only the building use, but it's the building location, it's the local codes. There are so many nuances with the weather resistant barrier. Having that person in your contact list and in your holster to help you with this selection is invaluable. I'll get off my soapbox on this. As we talk about these weather resistant barriers, we're talking about the impermeable and semi-permeable and permeable types of applications. For impermeable, you got rubber membranes, oil-based paints, vinyl wallpaper is one. Semi-permeable, plywood and OSB, fiber-faced isoboards. Permeable is unpainted gyp, plaster, unfaced fiberglass, lightweight impregnated sheathing. Some of your exterior gyp sheathings also are there. We need to ensure that if any moisture gets into the wall assembly, it can get out, and that the vapor doesn't condense and become trapped within that assembly. The whole gist behind this is that building envelope is designed to dry out. So we have to take into account the moisture accumulation caused not only by the exterior and interior forces, but you've got the manufacturing use, and you've got the construction processes, and you've got the construction materials themselves as they cycle through. So your weather barrier manufacturer can offer you various options to address those specific building applications. Not all vapor retarders are durable enough to resist air movement, and not all air barriers resist vapor drive, which is something that is out there, and it just reinforces the fact that not only based on your application, but your location and your codes, that you need to pay attention to your vapor and your weather resistant barrier as it goes through. Vapor flow through the building, it's measured in perms. If you look at a class 1 is less than 1 perm, you're looking at cheap polyethylene. If you look at 2, you're looking at fiber craft paper, expanded polystyrene, silver-faced polyiso insulation, and 3, latex and enamel paints. More permeability can be desired, and it can be combined with air tightness, and it offers an increased way or the ability for the assemblies to dry out. And the building use kind of controls the selection of those materials. So that needs to be taken into account early in the design. What we see is a lot of computer modeling with these building assemblies. Everybody's done com checks and everybody's used the Woofy Pro, and I'm not going to try to translate that warm window flesh in there. But there are debates among some of the experts that, the computer modeling is a great tool to have, but we need to use some common sense and use best practice approach to assembling the buildings, and use those in conjunction with the computer modeling as the building science increases in our assemblies. Just a quick shot of a readout, and you can see the temperature and the Wall assembly itself. And like I said earlier, we can do some pretty unique things with metal panels right now, and the design and the aesthetic has gone way beyond what we used to think of a single skin metal. Now we're looking at matching and enhancing the environment where the building is. But there are some other things with the wall assemblies that we like to bring up. Enhanced architectural detailing. You can curve the corners, you can round them off. You can miter the corners and have that corner and that profile actually do a 90 and return back and keep that continuous sleek straight line all the way through the building, all the way around if you so desire. The detailing. It's the details that make or break a project. Always has been, always will. Nothing worse than seeing one of these fantastic buildings and walking up during construction and seeing somebody trying to flash a electrical outlet with a 10-foot stick of J and a tube of caulk. It just makes you shake your head. I know that's something that I pay attention to that very few other people do, but with the lack or the unfunded QA and QC, we see more and more of it out there. And anytime we see it, it gives the whole industry a bad name. So pay attention to these little details because they can really enhance not only the look of the building, but they can enhance the operation of the building all the way through too. We talked a little bit earlier about some of the insulated metal panels that are out there and what we're seeing. We're seeing them being used as the continuous insulation. What we're seeing is if they're the assembly for the insulated, you've got the exterior face, which is the exterior skin. Then you've got your insulation, and that dimension changes depending on what you're looking for. You've got the interior metal liner, and it's assembled with clips more typically. So you've got concealed fasteners all the way through. And if you add the non-skinning butyl, you're actually providing that vapor barrier as well. So you're coming up with a single source. One of the big hits on the IMPs or the insulated panels was that the profile is not architecturally pleasing enough. So what we're seeing, not only are the insulated panel manufacturers coming out with more profiles, but we're seeing what we call backup wall systems, where the insulated metal panels are being used as continuous insulation. Then on top of that, we'll put a subframe of some type connected back in. And then on top of that, what a secondary single skin application. I have seen other manufacturers that are doing this with masonry. I have seen some that have stucco systems that they're using in conjunction with this. And I think the ease of application, number one, and the shortage in the labor force, this is something that fits into the fast track construction schedule. And you've got a single source responsibility, which I think a lot of your general contractors and your owners are looking for as well. The other thing is, and what we see coming down the road, is where that wall assembly actually becomes part of the building's operation. What we have here is a transpired solar collector. And what this does is this will take a wall panel, and this wall panel will preheat the air going into the building. And in a simple concept, what you're looking here is the warm air is pulled off the face of that wall panel, anywhere from 1 to 3 millimeters, and it's pulled into your collector area and up in and sent into directly into the building, in which case it will take and de-stratify that ceiling heat, bring it down into the onto the floor level or the working level, or it can be used as preheat for your HVAC system. There is a couple things to take into account, though. What you're talking about now is a solar collector assembly, and that assembly is normally anywhere from 4 to 8 inches away from the wall. So what you have there is a plenum that you have to pay attention to for the chimney effect. So behind that, you would need a weatherproof, fire-resistant wall assembly. And as soon as you say fire, you have to talk about Nfpa 285. It's the standard test method for the evaluation of fire. It's not a materials test, it's a specific assembly test. Single skin metal is great, and it's a desirable cladding because it's non-combustible characteristics, but it is an assembly test and everything gets tested within that assembly. A lot of your insulation manufacturers have tested assemblies as how they'll perform. In some cases, your air and weather barriers are part of that combustible material and have to be taken into account. There have been some revisions here recently, but those are very local. And another good idea to have your weather barrier guy up on your current codes. You know, some jurisdictions feel that they do not have enough fuel load to be included in those tests. And the recent update in IBC is also one of those. Just to show you a quick fire test assembly, what you'll see here is you've got a 2-story test chamber. There's a fire inside and a fire outside. With the new testing now, right in that window opening, you will see a joint in the wall assembly. That has been adapted and has been put into place. So that will be the new fire test that's coming out, and a lot of people have already tested to that, and that's kind of an ongoing thing right now. I like this. This is pretty much a quick cheat sheet, so to speak. If you look at what we have here, you know, is it non-combustible? Is it a commercial building for IBC? Is there foam plastic? If there's no foam plastic, is the exterior cladding combustible? If it's not combustible, is the weather barrier combustible? If it's not combustible, you know, then you follow the green line. If any of those other things you answer yes to, then you're looking at the NFPA 285. Just a quick shot where you line up all those joints. So, you know, what we're talking about is really scientific design principles that have been around a long time, and they have to be used in the design and the detailing of the project. They've come into play because of the recent energy code requirements, but they've always been around, and we kind of lost sight of those for a while in the construction industry. Be very careful of different hybrid types of systems. You know, hybrid types, especially with the pressure equalized systems, are kind of like opinions. You need somebody that has the engineering, has the backup, and has the ability to provide that to you to give you your desired results. The other thing is we've got multiple trades involved, and anytime you've got multiple trades involved, you want to allow for a redundancy in design. You've got the proper QC and QA that should be there, but we've seen in the process the QC and the QA have been diminished roles by the architects. You're seeing some of the diminishing returns of that as well. Your design should allow for address any construction tolerances in the field. And this is one of the things where MCA has come up and stepped up big time with their white papers and their technical papers. I use them quite a bit. I'm not only on the tolerances, but on the oil canning and how flat is flat issues. They have really made those available to everybody in the market. But when we look at some of the issues that we see concerning walls, depending on what you're doing here in conventional construction with wood or metal, what we used to see happen is you'd have, interior, you've got wallpaper and you've got your gypboard, and then you've got your interior finish and your insulation facing, your insulation, then you've got your permeable wall underlayment, and then you've got another sheet of plywood and your metal panel. And what has happened is you've pushed that condensation to the interior on the other side of your weather resistive barrier. The other thing that we see is a dual air and moisture barrier that traps any moisture inside the cavity, where you've got an impermeable wall underlayment and you've got your insulation facing, and that can trap that inside the whole cavity itself. This was a picture of a hotel in Florida. The thing, obviously it lost your integrity of your building enclosure, but this could have been a blessing in disguise. If the thing that caught my eye wasn't so much the fact that the wall was gone, but look what's happening on the inside of that wall assembly with the mold and the mildew. And that hidden area is what happens when you don't get it right. We used to put them up with 15, 30-pound felt paper and wood runners. We've seen this. We still see it in some applications. There are a lot better ways. The problem is the wood moves, the building moves, the panels move. Everything is joined in the assembly. So that has to be taken into account as that happens. We can use subframe members. We can use the new synthetics to get the desired results and make that building enclosure operate for the life of the building. Another thing is multiple material tolerance that you see. We'll see this a lot with the balloon framing that's out there right now on multi-residence type applications, where you've got multi-story buildings that are put up and they need to be dried in right away. Well, the wood might have been wet. And as that wood goes under load, as you start loading up those assemblies floor upon floor, that wood material will shrink. Well, your flashings and your metal that you put on don't shrink. And you'll get the oil canning, you'll get the warp, you'll get the buckling in those instances. Now it's recommended, and most of your manufacturers are doing this, where you're putting brakes at the floor lines to incorporate that with the multiple material applications. So just in wrapping up, what we're looking at is this assembly for a vented or ventilated type system. You've got on the left-hand side, you've got the counter flashing and that fastener flashing. That is all tied into your weather resistive barrier. if that piece of flashing is not there, you have added a element into your building where you're just going to rot from the bottom up. And that normally goes on before your exterior cladding. So a lot of times that'll be in place before your installer even gets out there on site. This is something that needs to be checked and looked at as you walk around the building. Before you put on any subframing or before you put on any metal panels, you need to make sure that counter flashing and that through wall flashing are installed and installed properly. And with that, I'd like to thank you for your time. I'd like to thank the MCA for having us in. And does anybody have any questions?
Dawn. No questions? Well, in that case, I'd like to thank you, David.
All right.
A great session. I'm wondering, for anyone who is interested, would you be okay with us sharing your PowerPoint?
Sure.
Okay. That would be great. Well, thank you.
Yeah, we'd be okay with that. And again, if anybody has any questions or concerns or would like to talk about anything, feel free to contact me directly. I'd be happy to help you.
You did get one question just came in. You want to see if we can answer it quick?
Sure.
Went away. Where did it go?
I got it. What testing has been done with Nfpa 285 and Rainscreen materials?
Excuse me? I didn't quite get that.
Look on your chat.
Oh.
Yep, 1 second.
Oh. Okay, here we go. What testing has been done with Nfpa 285 and Rainscreen materials?
Well, 285 is a building enclosure wall assembly test. So the Rainscreen materials, are you talking about the single skin cladding, or are you talking about the insulation, or are you talking about the space between? Because all three have to be tested. That total assembly needs to be tested. So a Rainscreen in and of itself is not an application.
There's one more question as well.
Okay.
Okay.
We've got one more
It's
question.
under questions. Q&A.
Sorry, we gotta find it.
Okay, I see one here from Dale Nelson.
Recovery system.
Yes. Normally, what I find, Dale, is typically you're looking at anywhere from 4 to 8 inches for that collector assembly on the heat recovery system or the solar application.
Great. We're getting a lot of requests for the PowerPoint presentation.
We'll email it.
For the PowerPoint presentation. So we'll just email it to attendees. We have your email addresses from your registration information, if that's okay.
All right.
There's one more message here. Let's see what it is. Yep, more copies of the presentation. We're just going to send it out to everybody who attended.
I do thank everybody. And again, thank you for inviting us to present this topic.
Excellent. Thank you, David. Thank you, everybody, for tuning in.
Thank you.